Good afternoon, everyone. Just come in, have a seat. It's the last session for today, so we just need to survive that one, and then we have some after party, I guess. My talk will be about Linux Spring Boot applications for the cloud, and I'm going to show you what I have learned within the last 1.5 years, playing around with Spring Boot applications with every single possibility of optimizing a Spring Boot application. Now I said it a nice way. Sometimes when I do my elevator pitch, I would say, Josh Long tells you just the nice Hello World example, but I'm going to show you how you can start up your Spring Boot application in half of the time. Your container images will be reduced by 50%, and you will have about 30% less memory usage in your application. So that's what I'm going to show you in the presentation, where I'm giving you some ideas how you can actually optimize your application. So that's actually what we are going to do. So just be aware of, I'm going to show you some numbers. And these numbers, they're done on my machine. So you cannot take them exactly from my slides. So you have to pay attention. You probably have a different application in production. So take it with a grain of salt. But my numbers will actually show you a direction, how you can optimize and what you could expect. And I'm also going to discuss with you the results. So that's why I say for educational purposes only, right? So don't take the numbers for granted. Just a few words to me. I'm Patrick. I traveled from Switzerland to Portugal to show you this stuff. I usually do consulting. I work with real humans, with developers on nice solutions. So we develop applications, obviously, and I help usually teams to get better and also to bring their application faster to production, in a better quality, of course. Besides that, I also teach at the University of Applied Sciences, and I'm quite a bit involved in the software development community in Switzerland. So I love to learn from and with each other. So that's actually my passion to learn. And obviously also Spring is one of the passion, because I started with Spring in 2007. That's quite a while back. And since then, I try actually also to teach software teams how to use Spring in the best way for their problem they have in production, I guess. So what is usually the problem? Why do we need this talk? And yes, I'm a Java and I'm a Spring guy. So I really want to show you that you can actually make your application faster, having better performance, and not maybe change to a different stack. So let's use the stack we have already, and let's squeeze out everything we could have. So the talk, why I'm going to do that talk is because we are going to move often application from a in-house setting into the cloud. And you probably realized when you're going to the cloud and you have less resources available. I mean, I have a situation where the customer says, you don't get even a full virtual CPU in the cluster, in the Kubernetes cluster. You might get a fourth of a virtual CPU or maybe a tenth of a virtual CPU. And if you see the numbers when the application is starting up, you're kind of shocked because it takes 2-3 minutes actually to start the Spring Boot application. And on my Mac or my Windows machine, doesn't matter which one I use, it's blazing fast, right? There is something wrong with that. And it's about resources in general. So we have to find out how we can optimize certain things. Let's dive into the topic. So the question would actually be, if somebody approaches you and says, you need to develop a new application, they might ask you what amount of resources do you expect? How many virtual CPUs do you need? How much RAM do you need? How much storage? And so on and so forth. And often it's quite difficult to give them a proper number because we don't know, and it just works on our machines, right? And even if you go to the technology stack, there might be other technology stacks which are slimmer than Java. Maybe also the application we build, if we do serverless or if you do long-running applications, the behavior of the application differs quite a bit. So we have to be clear about all these different requirements we have when we move our workload to the cloud. So let's have a look what we are going through in this presentation. So I'm going to show you the Spring Pet Clinic. You probably know that already. And it's the idea of the Pet Clinic to use the Pet Clinic for benchmarking that you can try it as well. So after the conference, you can get my slides and also like the examples in a GitHub repo, and you could see like what kind of optimizations I do, and I'm not benchmarking something I cannot show you, right? So that's why we use this. We define a baseline, then we go into some Java optimizations, we can do some Spring Boot optimizations, we have a look at some application optimizations, we may change even the runtime, and in the end, when I summarize it, I give you some thoughts, and I show you like how combined optimizations work together and how they could look like in the end. So this is actually like, yeah, you have to stay till the last 5 or 10 minutes, and then you will see like what it really does when you optimize your applications. So, yes. The Pet Clinic, you probably know, it's an application which is quite simple. It's a CRUD application. You can have like owners in there. You have veterinarians in there. There is even like in the navigation an arrow button which you can use to produce a runtime exception inside this application. It's quite simple actually. And if you go through the tabs, it might look like this. And there are also some pages where you have forms. So it's not really something crazy and difficult and a lot of business logic involved. It's quite a simple application. But it involves a few things. Besides that, I just want to highlight, if you want to learn a new technology, there is something on GitHub which is called the Pet Clinic Community organization in GitHub. It's not official from Spring, but I love it because if you think of like React, Angular, HTMX, if you want to do Vaadin or other stuff, you can actually like go and look how you would implement the Pet Clinic with this kind of technologies. And it's not only about front end. So there is like an Istio version, there is a microservice version. There's so many different versions as you can see here. So if you want to learn a new technology, maybe it's a good idea to have a look at a specific Pet Clinic, right? But yes or no, I'm not going to talk about those Pet Clinics. I'm talking about the original one, which you find in the Spring project organization. So it's just like the official Spring Pet Clinic, which uses the technologies like Spring Boot, Caffeine, Thymeleaf, Spring Data JPA. You can choose from H2, Postgres, or MySQL as a database. So for my purposes, I thought like H2 would be simpler to run some tests or some benchmarks because there is less to set up, obviously. And then actually you have also Spring MVC. Regarding the thing I mentioned, there is less to set up. I mean, anyway, you have to benchmark your application for yourself anyway, right? So that doesn't matter if I now use H2 for data storage or not. Even if caching is involved, probably it doesn't make such a difference if I would use now Postgres instead. Anyhow, so that's actually our technology stack. And with Thymeleaf, the application is just server-side rendered. So no single-page application, quite simple, the whole thing, as you can see. If you have a look at the technology stack in general, what I usually do now with the benchmarking, I'm using Docker containers, or I produce Docker containers with build packs. So build packs, you probably know, it's quite a nice technology. So you don't need to write your own Docker file, and you will actually, if you don't know about build packs, you will learn why they are so nice, and I think build packs are a great thing. For the baseline as well, I'm using JDK 17, even though it's a little bit older, right, and there is already 21 out there as an LTS version. 17 is a power horse. It's unbelievable, and I use that as a baseline so we can like compare against other versions. Then actually, like, I use test containers. I use Spring Boot in the current version, and also we have some migration scripts which are involved to migrate the application. And that's maybe a bad thing, because when you do benchmarking, when you check the startup time, you probably don't want to, like, all the time migrate your database. But it's part of the Pet Clinic, so that might be something we can optimize later. And then I'm looking at the data like build time, startup time, resource usage, container image size, and also like the throughput in the application. So build packs, I told you, I love it, and especially Paketo behind, which is kind of the implementation of the build pack spec. And they are awesome because they can convert any kind of technology you see on the slide into a container without having a Docker file. And it's even more beautiful because it's like a perfect container. A perfect container contains, for example, users. And the thing is actually like, if you use build packs, you will never run with a privileged user like a root user. You would actually see after the Packlinic logo, there is like the user which is used, which is called CMB in the output of the Packlinic. And the thing before the logo is also nice in the startup of the application because the build pack adds something called Java Memory Calculator. And the Java Memory Calculator is going to size your memory according to the resources specified to your container. So it's reading from the environment what is available, and then it will like optimize putting the XX parameters to your JVM and like does already some optimization, which is actually quite nice. And it does a few things more like updating the CA certs. It, for example, also like specifies the Spring Cloud bindings, so you have liveness and readiness probes for Kubernetes available like for the actuator, and a few other things. So it's quite nice actually to not think of this. And I usually say the examples you find in the internet using Docker files, there are so many levels wrong. So build packs just do it right in so many other levels, right? So it's way better. Anyhow, 1,000 times better than your regular Docker file. And another thing which is actually also nice, the build packs are maintained by the community, by the build packs community, so that means like you get fixes. If you think of like the run image which is used for the container, when, for example, a CVE pops up, there will be some updates very fast, usually like within 2-3 days when Canonical is fixing the stuff in Ubuntu, then it immediately gets into the build packs as well. So I think actually like it's the best way to do containers these days because it makes developers' life way easier. So I'm using that. Now think of this. If we want to get a feeling like where the application spends the most time during startup, and you don't want to use a profiler, there is a tool called Startup Report from Maciej. And Maciej has done a nice thing. He's just exposing a startup report in the browser. So just like for development purposes, you can add the dependency and you will see on the page like how long it took to initialize certain Spring Beans, or like a graph of the Spring Beans. If you scroll down on the page, you can see a flame graph where you can also see like which section took how long. And I think actually like when you look at the flame graph, and if you could read it from above, there's quite a bit of time which is actually used with Hibernate and Spring Data when the application starts. So like lots of time. I would say it's about the fourth or a fifth, which is actually just spent actually for setting up Spring Data. And you get this information because Spring Boot starts up anyway, measures this data, and Startup Report exposes this information. So try it out, and you will see like where you spent the most time during the startup in a very simple way. Let's talk about benchmarks. With the benchmarks, I am doing some benchmarking on the build, so I will use certain different versions, so you'll see like how long the build took on my machine. The output or the artifact created will be measured as well, like the size of the container. We measure startup time and memory usage. We also measure basically like throughput and latency in the application as well. And I do like a 1-minute warm-up and a 1-minute measurement just to stress my application. And for the example here, I basically like limit my container environment to 4 virtual CPUs. Because like the 4 virtual CPUs is like the sweet spot for the startup, but it will reflect also like in other topics so that you don't see the expected benefit, but I will tell you later where exactly. So if you're going to measure things, you will see here that I didn't do any adjustments. I just used like the current version of the JDK using the Java memory calculator in the build packs to specify the settings for memory and so on. And then you'll see the number below. right? Like 68 seconds for building with Maven. You have like 359 megabyte container image size. Startup took like 4.3 seconds. Initial RAM usage means just right after the start, I'm on the level of 302 megabytes. Then actually we load the application with 2,000 requests a second. So 1,997 get through within that amount of time. Then just right after the stress test, we see like 400 and almost 80 megabytes of RAM used. And then you see like the response times in the percentiles, how long it took to respond a request. So we'll use that as a baseline to compare all the optimizations against. So let's start with the first idea, because a newer Java version is always better. And it is, as you can see here, I'm just specifying also for the build, the JDK 21. And then you see, well, the image size got bigger, more features in Java 21, of course. Startup is even a little bit worse. We have initial RAM like on a similar level. And then actually like you see the numbers in the response times, actually they get better, even though the other things are not really great. Or not even like, well, they are still comparable, I would say. Be aware of that my numbers, they're made in a way that I test the things like 10 times. So I run like the benchmark 10 times. I strip off all the peaks. So that means like the worst and the lowest or the best examples. And then I try to do an average because I want to have a real life scenario. So be aware of that even like if the numbers are very close, it means like they're like on the same level more or less, right? So for me, actually, like doing this benchmarking already for a while, even the micro version of the Java thing, like the 17.11, makes a huge difference. So I have kind of the feeling that when the OpenJDK releases the Java version, they do the performance stuff afterwards. So you will actually see that even like going up every micro version, it matters. It matters in the performance quite a bit. So you could see that also like with the Java 22. So you see this one won't be an LTS version. So that means, yeah, on certain levels, it's also worse. Like, for example, the build time took way longer. And I checked really the number 2 or 3 times to not have some issues there. OK, so the idea would be, let's change the Java version to the newest LTS version because it's worth it. Let's talk about some Java optimizations. When using build packs, you can provide the Java tool options parameter, and you can do some nasty things like no verify. And that's not something you should do in production, but maybe during development it helps quite a bit. As you can see, we almost gain a half a second in the startup of the pet clinic. So no verify means basically the classes which are loaded are not verified. So that means the verification is the overhead, and we just turn it off. But actually, it's a security feature, so don't do it in production. Right. You can also, for example, instruct the garbage collector. And when you specify, not the garbage collector, sorry, the JIT, so the just-in-time compiler. So if you specify tiered stop at level 1, you don't get the C2 JIT, but you get the C1. And the C1 is actually not doing profiling and monitoring and other things, so no optimization will happen. So during the startup, they will optimize, yes, but afterwards, there is no runtime optimization anymore. And that's like what you see in the example here, that actually like when you put some stress on the application, throughput gets worse, and also the response times are way worse. And yes, you see it right. It's like 15 seconds at the lower right side. So if you do things like, for example, functions, then this might be a thing. Or if you think of like your IDE might start with the parameter because it's important that it starts fast, right? And you just like start it like once and then it's just running and it's okay-ish, right? But you don't have like lots of load. You will also see the tiered stop at level 1, for example, when the Spring Boot application is started within IntelliJ. So they just add that automatically. You don't need to do anything. So they add that so the application starts faster, just because you don't have load at development. as an example. So the Java tool options could be a thing where you can actually tell the build pack, let's add some parameters. And obviously, you could also change, for example, to different garbage collectors, if you like. If you have been today at Gerrit's talk about the different garbage collectors, you could go for the set garbage collector if you like to, right? And you would just specify it via the environment variable for the Java tool options. Okay, so there are many parameters or many optimization possibilities like garbage collector and other things. And I just want to show you there is a tool out there which has quite a good documentation on all the different Java distribution out there. You see actually like on the slide a documentation which shows like, for example, Dragonwell from Mali. So you have Amazon Corretto, you have Bells of Liberica and others, right? And you could actually see where the parameters are in the JVM and which are supported with which distribution. Maybe you have recognized before on the examples I did. Let's go back here maybe to this one. I'm using actually Bells of Liberica as a distribution because it's the default Java which is used for the build packs. And Bells of Liberica is just a distribution which you have anyway inside your IntelliJ. And it's also the version actually like VMware uses and the Spring team uses, which is, yeah, basically like the company which supports this kind of distribution. So you'll see actually also that you can actually change that easily if you don't like Liberica. So let's go back and let's talk a bit about Spring Boot optimizations. So how can we make now Spring Boot faster, not only like the JVM? And this is about, for example, having lazy Spring Beans. So you may know that if all the Spring Beans are lazy during start, they will be only initialized if you're going to use it. And you can save some time there quite a bit, as you can see in the startup phase. Besides that, actually the thing shouldn't change much, because if the application is like warmed, then the behavior should be like the same, right? It's really about the startup here. And that's also what you can see in the numbers. The numbers are really, really similar. Be aware of what I did here too is I made Spring Data lazy loading as well. So that means like Spring Data is also only initialized and hibernate behind when you have the first request on the application. So making Spring Beans lazy speeds up your application, but the first request is expensive. And be aware, you don't see it in the numbers here, that the first request is expensive, because we warm up before doing some benchmarking the application. So during the warm-up, all the necessary Spring Beans are already initialized, right? So here it's really about warm-up and startup, and you don't see it in the report numbers. So be aware of like having lazy Spring Beans. Means like the initialization is like deferred to later. So that means like after the startup, another thread is going to create the beans. So you are used to that your Spring Boot application is crashing when there is some misconfiguration. But here, when all the Spring Beans are lazy, the misconfiguration exceptions might happen later and on another thread. So it's not given that the application is crashing because something is wrong configured. So just be aware of this. This is really important to understand about lazy Spring Beans. So that means actually make some proper tests, and then you can actually like ensure that your configuration is correct in production. Another idea would be actually having the configuration location specified. And there is some different places where Spring Boot is going to look up your application properties and application YAML files. So usually it's like on the JVM working directory where you start the process. It checks if there is a config directory, if there is like in the current JVM working directory a file. Then it checks like if there is in the class path a package called config, or is in the class path on the root level a configuration. Just by specifying where you have these application properties or application YAML file helps already that Spring Boot does not need to do the checks. So that means like you will get a tiny bit of improvement during startup in the end. And all the other numbers, they stay the same. Now you could say, why is this guy here talking about that? The thing is just like if you're going to combine multiple things at once, you will see a big difference, right? So if it's multiple tiny things, you might see the things really. So that's why I'm telling you that could be a thing as well to optimize. And another idea would be actually like, and that's a brave one, to not use Spring Boot actuators at all. Really like, if you can afford not to use them, don't use them. But the other question is like, why would you not use them? Because it's about observability, it's about configuration. These endpoints provide you value in the most cases, but if you don't need to use them, you can get rid of them. So the thing is, what I want to show you here is like the extensive configuration which is needed to set up actuator. And you can see that in the numbers of the Spring Beans created, actually. So that means like the pet clinic with actuators has 452 Spring Beans in there, whereas the pet clinic without the actuators has only like 276. So that's like 170 Spring Beans less. And that means like that takes time, right, when you start up your application. So if you don't need some observability features or these metrics endpoints and other things, just don't do that. I mean, we would not use them because they are for free, right? They are not really for free. They actually have an effect on the startup, but also they have an effect when you put load on the application, because the measurement adds some overhead, of course. So be aware of this, right? So yeah, that's just a thing you need to think of as well. Now, talking about another thing, and this is something important because you should add that immediately to your application, is ahead of time compilation. Ahead of time processing is actually a step where when you build your application, there is code generated for you. And AOT is often used in combination with Graal native images, but you can use it without the Graal native images. So that means like what will happen is there will be code generated which instantiates the Spring Beans. When you do component scanning, for example, you would have to scan, and then Spring is using reflections to instantiate these Spring Beans. Now with the AOT step, code is generated to use code to register those Spring Beans. And it's aware of profiles and conditional annotations as well, so it's really baked into code. So that means no class path scanning needed anymore, no entity scanning needed anymore when you start your Spring Boot application, because it's just Java code you execute, and that's way faster. You should definitely do that, and it makes sense. So previously, like before Spring Boot 3.2, we had this Spring Context Indexer project, which was defining an index for all the components and entities. And now this project is deprecated because the AOT part is the replacement for it. So that means like there is no index anymore for component scanning, so you can keep the scanning on the class path in production, but now you have AOT instead. And basically AOT serves as a replacement for many other things as well. So what you're going to do, and now I'm showing some tricks, what you're going to do as well is you're going to add the execution part to your Spring Boot Maven plugin. And there is similar things as well actually for Gradle. And if you use build packs, please add this environment variable as well, where it says BP Spring AOT enabled, because it will do something. It will automatically add the property Spring AOT enabled equals true to your application as a system property when you start up the Java process. So when you use the build packs, this is actually like automatically enable AOT. If you only do the step for processing AOT and you don't set the property, it will still do the class path scanning and the entity scanning and so on. So it's necessary to have this additional property specified. And setting this environment variable for the build packs will do the job for you. Right. Great. There is another topic I want to mention. Obviously, like if you have things like JMX enabled, you should not do that, especially if you deploy to the cloud. But the thing is actually like if you run your Spring Boot application in IntelliJ, you will see that IntelliJ uses JMX to read the beans and the routes for Spring MVC and the health information for their IDE. So they're really like reading the JMX part. But actually, don't worry, since Spring Boot 2.2 and the build packs, the JMX stuff is disabled by default. So you don't need to worry about that because in Spring Boot, we always use production defaults. But I just wanted to tell you, you will see JMX actually running when you run your Spring Boot application in the IDE. Did I tell you that I like Spring Boot and build packs? So we have very good sensible defaults, and we basically do not need to think about like that we have the best configuration we need, right? So it's a lot hidden behind the scenes. Okay, so let's talk about some application optimizations. And in the application optimization, obviously, think of your application. You might optimize some algorithms. You might optimize some caching. You might even optimize some things when you connect to the database and you do some data migration. So for example, like with initializing scripts for the database or migrating scripts. I mean, that's a thing you can take out, and it's very specific to your application. So you know your application, and you know where you lose the most time. In this part, I'm not going to talk about those topics. I'm going to talk about the starters in general. Because the thing is actually that starters are meant to start your application, but I usually say they're not meant to finish your application. So the Spring team actually, with the starters, they specify an opinionated default. So for example, with Spring Boot Starter Web, they think that you're going to do REST services, that you have a single-page application and you serve the REST endpoints to this single-page application. But if you have a look at the Starter Web, for example, you will also recognize there is a Tomcat dependency for WebSockets in there. So if you don't need WebSockets, get rid of it, right? Or for example, if you don't need JSON because you generate the HTML sites on the server already, you don't need Jackson at all. So it really like is a default which is good to start with, but maybe not good to end with. And you have to be aware of this. So what I'm going to show you next is actually the thing that I found a tool which is quite nice. It's called the depclean Maven plugin. And the depclean Maven plugin creates a report and gives you some ideas which dependencies are used or not used. So they're using actually bytecode analysis to find out if some imports are really used or not. They will also check like for strings which identify usually a reflection as well. And it produces a report which looks like this, and I had to shorten it a bit because it doesn't fit the slide. So you see like the 3 points where I shortened the statements a bit. But the thing is actually like you would directly see which are the direct dependencies, which are the transitive use dependencies. You would even see like the dependencies which are actually not used at all. And obviously if you, for example, build an application like with web jars, they're referenced in the HTML file. So the tool won't find it, for example. Or other things, if you're using still a web XML, and you can do that with Spring Boot 2, I mean, you don't need to, but you could, or like other XML configuration files, then actually it's quite hard for the tool to find those things. So it won't find this. And it is also not aware of Spring Boot at all. So that means like the auto configuration imports file is not recognized. But the report though gives you an idea. Now let's jump back again. The report though gives you an idea which dependencies you can get rid of. And for me, for example, it was highlighting even like Hibernate, because they use some other magic to initialize. And then you know, yeah, but the application cannot deal or needs to deal with Hibernate. It's necessary, so you have to leave the dependency in, right? But other things you can easily remove. Think of the Snag YAML parser. If you don't have YAML configuration, you can remove it. If you have drivers in there which you don't need, remove them. And that means, like in my case, when optimizing the pet clinic, I could save roughly 5 megabytes. That's quite cool. So that means the image size gets smaller, the startup time gets better, because there is less to process and less magic needed, right? Well, be aware of that you need to clean up your dependencies. That's very important. So starters are good to start, but not to stop. Another idea what you could do is use another runtime. And with another runtime is maybe, yes, we may still use the JVM as we are used to, the hotspot JVM or the OpenJDK, but let's customize the runtime to the modules we just need, because JLink is a very nice tool which allows you basically to optimize your JVM according to your application. And the module system in Java was used basically for this. So we don't, as a developer, we don't use the module system when you write custom applications, but the tool here uses them, so we can strip off the modules we don't need. So that means actually, like in our case, for the build packs, we just instruct the build packs, and we say that we enable now JLink, and we shrink down actually like the image because like there are less modules in there. And you're just going to specify that single environment variable for the build pack, and the build pack will run JLink behind the scenes, and that's it, right? So the image size gets smaller, and because of some compression going on, because the JLink also will like compress the runtime, you have some slower startup times. I mean, you can write that you can actually specify that there is no compression going on, but then the image size will be bigger, right? So that's the thing. And now you see also some examples. I tried this with different versions, with the JDK 17 and also the JDK 21. That's why we have now 2 lines, and you will see it also for other examples. So it's about shrinking the JDK, so make the container image smaller. Yes. If you're smart, you can do better, right? So if you know which modules you use, you don't need a tool to guess which modules you use. So you can specify all the Java modules you want to. You can like say you want to compress it just with level 2 and not with level 6. You remove the header files, you strip out some debug information, you remove the main pages and so on, and you can still shrink down the JVM, the customized JVM quite a bit, as you can see in the results. We are saving 100 megabytes, right, compared to the baseline. That's quite awesome. And you see also with the timings, we are roughly in the same range, so we didn't like lose a lot, but we reduced network traffic quite a bit. Okay, now it gets more interesting because the next topic was introduced in Spring Boot 3.3, and this is pretty new. You may have heard of it, but you didn't see like how to do it. So AppCDS is actually an idea where you basically do a training run of your application. And when you start up the application, you will dump all the loaded class files in one single file. Instead of getting the class files you need during the startup, you load all the class files from this dumped file. You have a proper startup like usual, but the thing is actually like it's way faster. You just need to read one single file. And the cool thing about that is, if you're going to use build packs, you just say BP JVM CDS enabled true, and that means the training run is done for you behind the scenes. They dump the file actually in the container, and then during the startup, it will automatically read from that file. And I think I have it on the other slide, yes. So you see here that there is this application JSI file, which is actually needed to do the dump. So you see the first is like when you create the archive when the process is exiting during the training run. And in the Spring framework, they introduced like with 6.1 a feature called Spring Context Exit on refresh. So that means just before the bean life cycle is executed, we do the dump. So that means before the Spring Beans are created, the dump is done. So all these classes loaded up till then, they're dumped into this application JSA file. And then when you start up your process, and basically the build pack adds for you the shared archive file, it won't start from scratch. It will use that file to load those classes. And classes actually missed during the training run, they will be loaded the regular way. So there is no problem actually like that you missed a class or that you had a reflection in your code and you missed that class as well. So you don't need to provide hints or so. So in the end, what you need to do is just like specifying an environment variable for the build packs, and it's everything done for you behind the scenes. And you don't need to have something like a multi-stage Docker file or so. Awesome. Great. Did I tell you I like Spring Boot and build packs? It's so easy, and you can leverage like all the great new features, and it's just like there. Basically, the app CDS feature and the AOT feature is in the build pack since 3 weeks. So it's pretty new, and it's super cool, I think, because I don't need to know like how to do all the things behind the scenes. Obviously, you can go and check for different runtimes, and that means like why not to use like OpenJ9 instead of the hotspot JVM or the OpenJDK? You can do that, and OpenJVM is another implementation provided by IBM, right? And what I want to show you is actually like if you're going to specify in the build packs, basically the build pack for the OpenJ9, you can replace Liberica. So please get back. Yes, you can actually like replace Liberica with OpenJ9. And the lower line regarding the Java build packs, it's just needed that the Java memory calculator and other things will be added as well. Because the Java build packs by default contains Liberica, and I'm just like replacing that specific one. So I need to inherit all the other build packs which are still used. And I mean, as you can see from the numbers, startup times, throughput is well, yeah, somewhat okay. But what is special about OpenJ9 is memory. Memory is way better. So if you want to optimize on memory, why not changing, right? And sometimes, like in AWS, you have to think, if you need more memory, you also have to pay for more CPU. And that's maybe a reason why to change, right? You can also use GraalVM. GraalVM is actually nice because it's also JVM runtime. It has a better JIT compiler, actually, than the OpenJDK, so you just can replace it. With the downside, actually, that the image sizes get way better. But if you need a better JIT for optimization during runtime, you can change. And CE means Community Edition, because Oracle has a version which is way better, which all the other vendors like Red Hat and also Bellsoft and so on, they can't get it because that's proprietary software. And they also have a special licensing. So that means you can actually deploy your application to the cloud, but if you sell it within a product, you're not allowed to. Before that was an enterprise edition. It was called like GraalVM Enterprise Edition, and you had to pay for. Now actually like it's for free, but you're not allowed to ship it. Yes, and here actually the JIT is better and all the other numbers are better. So actually, if you choose the route with GraalVM, go for the Oracle distribution because like it's the fastest. Now let's think of build pack builders, and that's an idea where I said I don't want to use Ubuntu, but I want to use Alpine underneath. So let's use another builder. And the builder actually like provides here a possibility with Alpaquita, which is a Alpine distribution, which is quite tiny. And there is a glibc version and a Muscle version. So glibc is like the hacky implementation. Muscle is more secure, but they're also slower. And you just can say, let's exchange now the Ubuntu, which is in the container, with an Alpine, and you get this, right? So you can see image size has drastically changed, and the glibc. And yeah, it's roughly on par with what we had before. Since like the Bellsoft builder is only like capable to work with Java 17, for Java 21 I had to find another way, and there is a tiny builder. So the build pack by default uses like the default builder, not the tiny one. So that means like if you choose the tiny one, which is usually used for GraalVM native images, you can do Java with that. And it gets tinier even. So that's awesome, right? That's just like another way of optimizing things. Of course, you can go with Graal native images as well. So let's compile that into native code. And we know that GraalVM starts up faster, but there are also some drawbacks. So if you have really crazy load on your application, maybe the GraalVM native image is not the thing you want to use, because the optimization steps at runtime is not that awesome. So yes, so you have to think of like where you want to optimize. But I just give you possibilities, right? And there is another thing, around the corner, which is called crack, which is actually meant that you are going to snapshot your application at runtime, and you can restore the snapshot. But the problem is actually like there are two distributions out there, Azul Zulu and Bells of Liberica have an implementation of this, and it only works with Linux. So Azul has a version which is actually also kind of simulating for Mac and Windows the thing, so that you can develop software, but it really it's natively working only with Linux. And well, the thing is actually you would have to do it by hand because there is no build pack there yet. So that's a problem. And we also have like other problems regarding, for example, secrets, because if you dump memory into files and you want to restore them, so that means you would have your credentials in the dump. And that's a bad idea. And it doesn't work with multiple environments where you need to use different credentials. So at the moment, they are like trying out what we could do to basically like create a build pack for that, right? And the problem is really like, yeah, there are challenges quite a bit, and the environments and the operating system and so on. By the way, OpenJ9 has Creo support, which is basically the same like crack for the OpenJDK. I cry because there is no build pack for Spring Boot, right? So that's really sad, but we'll see. I'm sure there will be some in the future. Now the last topic will be about like virtual threads. And virtual threads are awesome, and you should enable them, especially if you have less CPU. In my use case, the numbers don't look so great because I do the benchmark with 4 cores, and there you just like get a tiny amount of benefit. So it's like between 10 and 20% usually. But if you have like a half a virtual core, for example, you can get like 1,000% better data. So the less CPU, actually like the bigger difference you see when you use virtual threads. And the virtual threads is just a thing you easily enable with a property, as you can see here, and you turn them on, and then Spring Boot is just going to like, yeah, instruct, for example, Tomcat and other things with virtual threads. So let's summarize everything. You have seen quite a bit of optimization steps. And yeah, that's quite nice, and you probably learned like one or the other thing, or maybe you need to go and check things later again. That's a great thing. So be aware of that, as I said, a Java process by default starts the best if it has 4 cores. If you have 2, it's kind of linear, the numbers. If you have less, it's even worse than linear. So be aware of that. But usually in the cloud, you don't want to spend so much CPU on an application which is mostly idling. So you are aware of that it starts very slow, and you can deal with that. That's maybe just okay. Be aware of that the numbers you measure on your application, they count, not mine. So you have a different use case than I do. So please be aware of this, right? And also, there are other runtimes out there where you can pay for, where you put money on the table, and they have a reason why you pay for. Better optimization, better garbage collector, better other things. So there might be like reasons why you go and pay for a license. And obviously, like all the big brands, they have support or special editions, and so on and so forth. And then actually there are other ideas, like the crack I didn't try. I didn't try yet some obfuscation of the code as well. I could even do some further optimizations on the JVM and even use like Project Laden, which is actually also meant to like strip down the startup times of your Java application by half. So this is kind of like what's going on in the future. Yes. So now let's have a look shortly at the optimizations. I applied kind of a summary of everything, so you see the final numbers. And I just tried to apply as many things as possible. So with the Bells of Builder, you have like Java 17. You see like the lazy initialization. You see basically, well, you don't see it, but also like I reduced the dependencies, for example. I used AOT as well. I used, I think, even AppCDS here as well. And you can see basically like startup time got half just by applying all these ideas. And you can also see like with the numbers, with throughput and response times, they're like still in the same range, right? That's quite awesome. And The other thing is actually like in Java 21, you would use a different builder, and we would enable even like virtual threads. And there you can also see we have a significant better startup time, image size is less, and then also like if you look at the numbers, they are kind of comparable. So and be aware of that my machine was just like too beefy with 4 virtual cores. If I would have done that just with a fourth of a core, then actually like with virtual threads, it would even look better with the numbers of the latency. Yeah, so that was it. Did I miss something? Please let me know. Let's discuss. Maybe you have some ideas. Maybe you learned something. And if you want to share something with me, please do, because I also still want to learn. And I started the journey like 1.5 years ago, and I learned quite a bit during that time. And I'm constantly adding and updating and trying new things. That means new Java versions, new Spring Boot versions, and other things. So please share your ideas. And I'm sure I'm there also for a beer afterwards. Thank you very much.